Hi, today I would like to continue my previous tutorial where I was starting to build a routine for evaluating simple formulas into a reverse Polish notation. And at the first step, uh, the the first element of this code was to split the string which contains the formula into individual segments or tokens which can be used for the creation later on for the reverse Polish notation. The reverse Polish notation makes the reading or the evaluation of a formula much more easier for the computer, because you can basically define a very simple way how you need to calculate a formula instead of the normal or simple notation what we use in the practice for showing a formula. And actually for us as a human, because we know the rules, um, the evaluation of such a formula uh, is uh, is not that difficult, because we know which element or which portion of the formula should be evaluated first, and typically these are shown by the brackets, or you have certain rules, like if you have longer elements in the numerator or denominator, then you know that how to calculate that. So basically, you are replacing the some elements maybe with brackets in the practice, and then you make the calculation. But this means that you are not just simply going from left to right or from right to left or whatever simple way of making the calculation. You might be starting to simplify the formula itself by calculating certain portion, and then you replace those portions with a number. The reverse Polish notation basically removes all the brackets or parentheses from the calculation, and provide a clear left to right approach to calculate the formula itself. So I just typed here a formula where I have three elements in brackets, and within the brackets I also have some priorities to make the calculation. So in the first bracket segment I have the 3 divided by 2, which we need to evaluate first, and then we can make the division or the subtraction here. Then basically all brackets portion can be calculated individually, and finally you can make the addition. However, in the reverse Polish notation, if you already have a result and basically you calculated the first two elements, you can already add them together, and then you can continue to finalize the calculation. So how it looks like in the reverse Polish notation is you can already see here, because I already have this reverse Polish notation formula created. Not yet the final calculation, but just the formula creation itself. And as you can see, the above formula here with the brackets is the formula or the original formula we're starting with, and this is the reverse Polish notation form of it. And as you can see, we have an order here from left to right, and the calculation method for the reverse Polish notation is that you might have a function with one parameter, you might have an operation with two parameters. So basically these are coming after each other. So once you want to evaluate this formula, you just simply go from left to right, and every time you find an operator or a function, then you can already make the calculation, and you can replace the operators or the values. Once the calculation is done, that little portion can be, let's say, replaced with a value. So for example, if we start here the calculation, as I said in the first brackets, we need to make the first calculation that we divide the 3 by 2. So when we are going left to right and we are reaching the division character, then we can take the two elements here, and we can divide these two with each other, and then we can replace these 3 characters with the result. This will mean that we will have the 7 and this result here and the minus. And when we are going further, then we can make the next calculation. So we can take the minus, we can take the 7, this result here, and then we can get the 7 minus this value, and we can again replace this element with a number. And then you can see we will have 3 numbers here. So we can go again to the right. We reach the multiplication, so we multiply the 6 with 2, and then we have again a number, so we go further to the minus, and then we have this 3 and the 2 result also replaced here, and then we can divide from this result the 5, and then we can replace this portion again. And if you remember, we had already one value from this, one value from this, and then we have a plus. So this shows that we can add together basically this part of the calculation. So this one will be again replaced by one value. And this is exactly what we see here, that if we add it together here, we already have one value, and then we can go further in this calculation. And this rule is basically makes this easy. So actually, if I change the calculation, that I put the 7 at the end of the calculation itself, I mean in the first brackets, and I run it again. If you remember, in the previous method, the 7 was in front of the 3 and the 2. So now, because I changed the order of the calculation, of course, now we are not, let's say, subtracting the 3 by 3 divided by 2 from the 7, but we are make the opposite. So here the order also changed. So the 7 is now not at the front of the calculation, but at the end of the calculation. And then, of course, the method is the same. We divide the 3 by 2. We replace this 3 with the number, and then we will have the result minus the 7 because of this calculation here, and so on and so on. So basically, that's the method. And the formula which is creating this reverse Polish notation can even handle, let's say, more complex formulas with functions inside. So now I create one like this. So now let's like this. So the x plus epsilon squared, and then the sinus of this, and let's subtract by 10, and then we multiply it with 6, and so on. So now the formula look like this. So if we go through again, you can see that the 5, 6, x and y is at the beginning, and here when we start to evaluate, of course x and y should have a value, otherwise this will not work. But at the end, if we replace these with values, like I will use these variables later on here, and even I could be able to replace this one with a variable. So let's add a data field here, and let's add another data field here. Then we can basically um, create a kind of complex formula with database values. And as you can see, it was just replacing the variables here inside the calculation. So again, moving from left to right, this is exactly doing what was explained. So the variable 1, variable 2, add it together, and then we have a square function here. So we calculate this one. Then we have a sinus function. So we will evaluate the sinus function. For this we need only one variable. So basically what is coming out from this result will be calculated and placed into to the place of this one. And then we need to have a minus 10. So we make the minus 10, and then we can make the multiplication, and then we can make the addition. So basically this formula is working on the right way. When you want to create the RPN formula, you need to have the tokens ready, and then you need a stack. Basically the stack will contain those elements which you can't evaluate immediately. So this will be basically handling those elements where you have a precedence issue, or you have a parenthesis, because these parentheses are creating the priority basically. So these elements which are in brackets, these needs to be evaluated before others, and the more parentheses you have, the higher you are in the priorities. So basically to put something into the stack means that that you need to evaluate it only later. Otherwise, in the RPN formula, you will not be able to follow the left to right evaluation. So then of course you have an output, and into the output you can put those elements which can be immediately calculated, or if you have a closing bracket or parenthesis, then you can put everything from the stack what you collected there into the output, and then you can make the calculation. After initializing the formula, I mean the splitted formula, this splitted formula can be put into the tokens, and then the evaluation can be started. So the code itself is basically going through each individual tokens, and take the token into a very complex statement actually. So basically based on what is inside the token, if it is a function, or or a number or a parenthesis, then you need to decide what to do with it. So basically the first one is checking if the token itself is a value or a variable. And if it is if it is a variable or a value, then it can be put into into the output itself, because that can be already let's say part of a calculation. And then going through the different elements. So if it was not a number but it was a function, then the function should be put into the stack, and this will basically change the order of the calculations, because if the next one is a value again, then this value go into the output again. So basically the first, for example, if I have a plus 5 plus 2, then the 5 will go into the output, the plus will go into the stack, and then the number again will go into the to the output. And then because I don't have any more items, I can go to the end of the function itself, and basically this last portion of the code will make sure that everything which was in the stack will be moved into the output. So basically if I just have this two elements, then the two variables will go into the output. So the first two items in the output will be numbers, and then the last one will be the plus sign. If I have a more complex thing, then we can go through again. So if it was an operator, of course, if we have a function that that will do the same. So here we have the function, here we have the operator. So if we have an operator, then we need to decide if this operator is let's say a higher priority operator than the previous one, because if the previous one is a higher priority operation, then it needs to be evaluated first, and then you can go to the next. So basically with this here this while statement is simply checking if we have a higher precedent operation or we have a lower one. Then we need to decide if we put the stack into the output, or we need to still put everything into the stack. So with this basically the calculation itself is created. The next thing what is required to be checked is the parenthesis, of course. If you have the parenthesis inside the calculation, this should be finally removed, but at first we need the opening character we need to put into the stack, because this will tell for a later calculation when we are within brackets. And if we are within brackets, then when we find the closing bracket, then we need to basically empty the stack again, because we need to make that calculation inside these closing brackets, but only until we find the first opening bracket. And this is basically what this portion is doing here. Of course, when you find these opening characters, then the opening character should not be put into the stack, or it should not be put into the output, because we are basically at the end removing all the brackets from the calculation. And Basically, that's the calculation. It doesn't seem too complex, but you need to consider many things, of course. That basically you need to formulate how you would solve the calculation, but you need to go into a logic that if you can calculate something already or not, and then what to do with that. So you need to put aside those things which you can't calculate immediately. You need to put them aside and just move forward to that place where you can already make a calculation. So that is basically the logic behind, and as you can see that once everything is finished, and you might have remaining characters in the or remaining operations in the stack, and then those can be put it at the end of the output. And here the last part of the code is just to basically show it in the console output that how the formula itself was transferred into the RPN format. And of course, this one can be let's say changed on a way that you might have a different way of working. Of course, here you need to always use the brackets wherever you don't have it in your written formula, let's say. So if you take a formula from a book, you might not have some brackets um used in this typed formula, let's say, like typically if I would have such a formula like let's put something into the end as well. So basically, once you have a formula in a book, like this denominator here is should be under this division, then typically you don't have the brackets around this calculation here. Sorry, this calculation here. But if you want to type it correctly, then you need to use it. Otherwise, you get this RPN formula where you can see that the minus is actually at the end. However, you should have the division at the end. So to correct this formula, of course you need to put this into brackets because this calculation needs to be under the denominator completely. And with this, pressing the check, here you can see that previously I had the minus at the end, but in this case this division is at the end. So if we go through again, x plus epsilon is calculated. We take the sinus of it, and then we can continue. We have the plus, so we can add together the x and the epsilon. Then we can calculate the cosinus of this, and then the next one that we have to subtract the 10 from it, and then we can divide the sinus result with this result under the division sign. So this is basically how the computers are doing calculations, because at first to convert it into the right order, make sure that that the calculation is done in the right way. Okay, so this is for today about the RPN formula, and because the next one will be the calculation itself with real values, I will also create for that a tutorial. And if you would like to be notified about this, then please don't forget to subscribe. And with this, I wish you happy coding, and see you next time. Goodbye.